So I'm going to be showing you guys how to solve for trigonometric equations using the general form of the solution for either sine, cosine, and tangent. And there's always three things that you're going to want to do. First, you're going to want to solve for the trig function, so isolating sine, cosine, or tangent by itself. Then we're going to want to use the inverse function to solve for one solution, and then we can finally plug it into the general form of the solution. So if we look at 2 sine x of -1, we're going to first want to isolate sine by itself. That way we can solve for sine x. So to do this, we can add 1 to both sides, and then we're left with 2 sine x is equal to 1. So now we can divide 2 to both sides to get sine by itself. So we are left with sine of x is equal to 1/2. And in order to solve for what x is for one solution, x is going to be equal to, remember how I told you guys can find the inverse, the sine inverse of 1/2, and then that will tell you what x is. You can either use your table or a calculator to find this, or the unit circle. If you use your calculator, you're always going to want to make sure that it's on degree mode. So you're going to go to mode, go to degree, and hit enter. That way you get a nice number instead of a decimal for radians. So to get to sine inverse, you're going to want to hit second and then sine, and then you can plug in your half, your 0.5. 0.5 is a half. So our degree is 30 degrees. So our degree is 30 degrees, and if we wanted to set it in radians, 30 degrees is pi over 6. So this is one solution that we can use. So in this step, this was our first step. We've solved for sine. And then this was our second step because we used the inverse function to turn it into our solution. So our final step is to plug it into the general solution. So we have that x is equal to, we have -1 to the n power. So I'm plugging it into this solution because we're talking about sine. Sine inverse, our sine inverse was equal to pi over 6. So that's going to be times pi over 6 plus n pi, where n is equal to 0 plus minus 1 plus minus 2, so on and so forth. So we have this as our final solution. And that's it. That's all we have to do. So it's not too bad. All we have to do is follow these same steps. So let's try another one. For tangent, even though this looks like a weird equation, it's similar to a quadratic equation because of this x squared. You can think about it as x squared function. If you feel comfortable, you can write it as x squared plus 2x plus 1 equal to 0. And then solve for it like a regular equation. But if you're comfortable with keeping it as tangent, you can keep it as tangent as well. So usually, whenever you have something being squared as a quadratic, what you can do is factor this to solve for x. So if we factor, we want to open up our two parentheses and set it equal to 0. In the first part, we usually write x, and since our tangent x is kind of like x, we're going to write one tangent x here and another tangent x here. And now we're going to want to think, it's the same as regular factoring. You're going to want to think of a number that multiplies to give you 1, but adds up to give you 2. And that is 1 and 1. So we can say tangent plus 1 and tangent x plus 1. So this is how you factor this whole equation. And now we just want to solve for x. So what we usually do is we set both parentheses equal to 0. So we can do the same thing here. So we have tangent of x equal to 0, and then tangent of x plus 1 equal to 0. So now we're just, again, going to solve for x. So we're going to subtract 1 to both sides, and we have that tangent x is equal to -1. And then the same thing is going to follow through on this side. So here we're also going to have tangent of x equal to -1. And if we plug this into our calculator, again, we're going to want to solve for x. We're going to say that x is equal to, so remember, to get whatever x is, we have to do the tangent inverse of -1. So our x is, so we're going to hit second tangent to get that tangent inverse, and then you can plug in -1. So our answer is -45. So one solution that we got was -45. negative 45 is the same as saying negative pi over 4 in radians. So if we plug it into our solution here, we have that x is equal to negative pi over 4 plus n pi, where n is equal to 0 plus minus 1, so on and so forth. So that's what we usually do. So that's how you can find the solution. For the next problem, now we again have another quadratic equation. This is a quadratic again because of the squared. So again, we can do the same thing. We can try to factor this. So once we factor, we again have to open up our two parentheses. And now we have to think of two numbers that multiply to give you 6, but add up to give you 7. So the first thing that we have to do is we have to add cosine x here. Just like we would add x in the normal case, we're adding cosine x. And now, so we're going to have to think of two numbers that multiply to give us 6 and add up to give us 7. So that would be 6 and 1. So now we just have to set both of these equal to 0. So we're going to set cosine x plus 6 equal to 0 and cosine x plus 1 equal to 0. So from here, we have to solve for each one. So we have minus 6. We can subtract 6 to both sides to get cosine x by itself. So on one side, we get that cosine x is equal to negative 6. And on the other side, we can subtract 1 to both sides. So we have that cosine x is equal to negative 1. So here we have two solutions, but let's try to see what they are. So on this side, cos x would be equal to get rid of cosine, we have to do the cosine inverse of negative 6. So x would be cosine inverse of negative 6. Let's see what that gives us. If we do the cosine inverse of negative 6, we get that it's not a number. That is because the unit circle only goes up to 1 and negative 1. So because 6 is smaller than negative 1, this cannot be a solution. So this is not a solution that works. And now let's try to test out our x value for negative 1. So to solve for x, we're going to do cosine inverse of negative 1. So if we plug that into our calculator, we do cosine inverse. So we're going to hit cosine inverse of negative 1, and we get 180 degrees. So here, this is equal to 180 degrees. And remember that in radians, that's just pi. So if we wanted to write our solution would just be that, our general solution would just be that pi plus or minus pi plus 2n pi. But if you guys look at plus or minus pi, on the graph, if you go forward 180 degrees, that's going to give you at 180 degrees. But if you go backwards, that's also going to give you that same point. So plus and minus pi is the same thing for both positive pi and negative pi. So because of that, you can simplify this to just saying positive pi plus 2n pi. So this is what your general solution is. And again, where n is equal to 0, plus and minus 1, plus and minus 2, and so on and so forth. So that's going to continue. And this would be our solution. So that's basically it. It's not too bad as long as you follow these three main steps. So it's always going to follow the same form. You're always going to want to solve for the trigonometric equation. You're going to want to isolate sine, cosine, or tangent, whichever you're dealing with. Then find one solution using the calculator or table or unit circle, whichever you like. And then just plug it into the general solution form. And that's it. Here are 3 examples that you guys can try out. And in the next video, I'll be solving these for you guys. So you guys can try these out and then click on the next video. Make sure to subscribe to get the latest videos and check out if your answer is right or wrong. Take care, guys.